Hey everyone, today we're going to be talking about homework number 22, which was out of section 14.3, which was centered around right triangle trigonometry. Alright, so let's just kind of jump right into this. First question is kind of its own section, so I'll just kind of get you set up in this one. So, on this one I gave you a right triangle, looks something like this. This is the horizontal line up top. I told you that this height was 3,000, and we have an angle of depression of about 20 degrees. Alright, so with this question, it says from a hot air balloon 3,000 feet above the ground, you see a clearing whose angle of depression is 20 degrees. Given that the sine of 20 degrees equals 34 hundredths, the cosine of 20 equals 94 hundredths, and tangent of 20 equals about 36 hundredths. Okay, so this is all I've given you, and it says find each distance to the nearest foot. So first we're going to find the horizontal distance, which would be right up here. Alright, so since I know I'm looking for this distance, and I've been given this distance of 3,000, I'm going to look at this angle that was given, the angle of depression. I'll just kind of call it angle A. And I know that I've been given its opposite, and I'm looking for its adjacent. So the trig function that I want to use is a tangent, because tangent deals with the opposite and the adjacent here. So I know that the tangent of 20 degrees equals 0.36, but I also know that's equal to opposite over adjacent because of SOHCAHTOA, so I know that's equal to 3,000 over x, which is our horizontal length up here. Alright, so now we just got to solve this thing. So let me kind of just move everything up for you guys. Alright, so we've got the equation 0.36 is equal to 3,000 over x. So what I'm going to do is multiply each side by x. We're doing this because we don't want our variable in the denominator, and what that does is cancels out my x's over here. So now on the left side, I'm left with 0.36x equal to 3,000. And our last step here, we're just going to divide by 0.36. Alright, so now we just plug that into a calculator, and we're going to get that our missing side length was 8,333.3 repeated, but it said to round to the nearest foot, so we'll say that this length was 8,333 feet, right on the dot. Alright, so that would be doing part A, and the only difference for part B, this one I'll just kind of broadly set up for you guys, and I'll let you take it from there. For part B, I'm looking for the direct distance, so from here directly to here. So now you're just finding the hypotenuse. So you'll set it up the same kind of way, but this time we won't use tangent, because tangent doesn't have anything to do with the hypotenuse. So we'll either use sine or cosine, whichever one you want to do there. Alright, moving on to question 2. I've given you a triangle over here that looks like this. It's A over here, B over here, C here, and I gave you all the side lengths. Alright, this one just asks us to find all of the trig ratios and then round to the nearest hundredth. So I'll just do A for you guys, and then you can take it from there. It shouldn't be too bad on this one. So for A, I'm finding the sine of A. So remember, sine, that was our right angle, is going to be opposite over hypotenuse. So opposite is here, hypotenuse is here. So I know that the sine of A is is equal to 15 over 17. And when we calculate 15 over 17, we will get sine of A is equal to 0. And we said round to the nearest hundredth, so I've got 0.882. And remember, when we're rounding the hundredths, that's 2 decimal places, and this 2 we just drop because it's less than 5. So we just get 0.88. Alright, moving on to number 3, I told you that in triangle GHI, angle H is the right angle, GH is 40, and G is 40 over 41. So draw a diagram, yada yada. So what I'm going to do is I'll just draw the diagram to get you guys started, and then it's just like problem 2 like we just talked about. So I think you should be able to take it from there. So on question 3, I know I have some right triangle. I'm just going to draw it super simple, just like that. I was told that angle H is my right angle. So now I'll just say this one's G and this one's I. Okay, and I know that the side length GH is 40. So there's that side length. And I know that the cosine of G, so the cosine here, is 40 over 41. And remember, cosine is adjacent over hypotenuse, which would be here. And like we're seeing in our fraction, the adjacent is 40, which is good because the numerator of fraction is 40. So that tells me that the hypotenuse right here is 41. So remember, now we're going to need this side length before we go too much further. So finding this side length, we're going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. Here we know our a squared would be 40 squared, b squared we don't know, and c squared would be 41 squared. Alright, move that up. So when we start solving this, we get 1600 plus b squared equals 1681. Now it's just simply solving an equation. Subtract 1600 from each side. And I get b squared equals 81. Now we're just going to take square root, and we see that b equals 9. So our side length here is 9. So from here, you should have a pretty good idea of what to do. We're just going to set up, I believe I asked you for sine, and sine of G, sine of I, all that stuff. So just follow your notes along, and you should be able to solve from there. So again, we figured out that this was 9. Now we have all our side lengths. Now it's just plugging it into the ratios. Alright, the next set of problems has you guys doing 5 and 6, so I'll just go ahead and do 7 as an example problem. Sorry, the screen's being a little weird. Alright, in 7, we have this triangle up here, and I gave you side length 7.9. I gave you this angle is 48 degrees, and we're looking for that right there. So we always start at the angle, and if you notice for our angle here, we know that I was given the opposite angle, or opposite side length, sorry, and we're looking for the hypotenuse. So we want to use the one that's O over H. And if you remember, that would be the sine of 48 degrees equals O over H. Okay, so first thing we're going to do, we can plug in and just do the sine of 48 degrees. Alright, so when I plug in the sine of 48 degrees into my calculator, I'm going to get the following decimal, about 0.743. Make sure your calculator is in decimal mode, not radian mode, or you'll get a very different answer there. Alright, and then I know that's equal to opposite over hypotenuse, which is 7.9 over x. And now we just got an equation to solve. So again, I don't want x in the denominator, so I'm going to multiply each side by x. And that resulting equation is going to look like this. 0.743 equals 7.9. Oh, there's an x on the left side. Okay, now we just divide by 0.743 to each side. And we get our final answer of 7.9 divided by 0.743, which gives us a grand total of 10.632, but I asked you to round to the nearest tenth, so 6.3 would round to just 6, so we just get 10.6 there. Alright, the next problem set has you guys doing 10, 11, and 12. These are really just, can you plug this into a calculator? So let's just kind of look at 13 really quick. I'll just do it for you guys and just make sure you get the same answer, and then you should be fine. So on 13, we're doing the inverse sine of 0.335. So literally all I'm doing here is going to my calculator, and I see that behind sign written on my calculator is sine to the negative first. So I'm going to click second sine, and then I'll just type in 0.335. And that's just going to pop out about 19.57, which is going to round up to 19.6. So that's all you got to do for those ones. Alright, the next set has you guys doing 18, so I'll just do 19. The big thing here is just draw your diagram. If you can do that, this shouldn't be too bad. So I told you that there's a triangle ABC. Has a hypotenuse, or the 90-degree angle is at C, and then I need to find the remaining sides and angles given a couple pieces of information. So on 19, I told you that side A, which would be the one across from A, is 5, and side B, which would be the one across from angle B, is 6. So really on here, we gotta find our missing hypotenuse first. So again, we're gonna jump back to the Pythagorean theorem, and I have 5 squared plus 6 squared equals c squared. Here I'll get 25 plus 36 equals c squared, and that'll give me 61 equals c squared. And then last but not least, we just take the square root of each side, and the square root of 61 will get me about 7.8. So C is about 7.8. Okay, that's our hypotenuse. Now we have all of our side lengths. So from here on, it's really not too bad. Just choose one of them. Say like, if we're going to look for A, we could say the sine of A is equal to its opposite over the hypotenuse. So you're just going to calculate what 5 over 7.8 is, and that'll give you angle A. Then you can find B, and then obviously angle C is pretty simple from there. Alright, in our second to last problem set, you guys are doing problem 25. So I'll go ahead and look at problem 26. Just like the last problem set, it's really, if you can draw this thing, it shouldn't be too bad from there. So on 26, I told you that the cosine of theta is equal to 7 over 20. Sorry about the screen. There we go. 7 over 20. Cool. Alright, so first thing we're going to do, just draw yourself a right triangle. Label your angles. We got angle A, angle B, angle C. And let's say, we'll say that theta is up here. Let's say angle A is theta. Alright, so I was told that cosine is a 7 over 20, which means adjacent over, adjacent over hypotenuse. So 7 is our adjacent, 20 is our hypotenuse. So they go there and there. And now it's pretty simple. Just like the last couple problems, we just gotta find our missing side length first, and then we can kind of just rock and roll from there. So remember Pythagorean theorem, 7 squared plus, we'll call this x squared, equals equals 20 squared. So we get 49 plus x squared equals 400. So I'll get x squared equals 351. And then we just take the square root of each side. And when I take the square root of 351, I get about 18.7. So that tells me right here, x is about 18.7. Now, from here, you can pretty easily find cosine of theta. You'll just do, or we have cosine of theta, sorry. We'll find sine of theta, which would be opposite over hypotenuse, tangent, all that good stuff. Alright, to finish things up, you guys have problem 37. The closest one to that is 38. So again, if you've been watching this whole video, kind of starting to sound like a broken record. Really, if you can draw the diagram, you've got this thing. So we've got question 38. And on 38, I told you a couple things. The measure of angle A is 34.2 degrees. And I told you that side length B is 5.7. Okay, so we're just going to draw ourselves a triangle. They're all right triangles. This might not be exactly what it looks like, but I'm just going to start with a really basic right triangle. And let's just start labeling some stuff. We've got angle A, we've got angle B, and we got angle C, which from the directions told us that angle C was our right angle. Alright, so I know that angle A, this one right here, is 34.2 degrees. And I know that side length B, which is across from angle B, is 5.7. Alright, so at this point, there's a couple ways we can start. I always like to start with getting all my side lengths out of the way. So what I'm going to do here, move this up, give us a little room to work. I know that I can use the Pythagorean theorem once I have two sides. So I'm just going to go down here and try to find this side. So if we're starting at angle A, because I know the measure of angle A, I'm going to use one of the ratios that tells me adjacent and opposite. And hopefully you remember that's tangent. So I know that the tangent of 34.2 degrees is going to be equal to opposite over adjacent. Okay, at this point I'm just going to jump to my calculator and figure out what the tangent of 34.2 degrees is. And that gets me about 0.68. And that's equal to x over 5.7. And on the right side, we just see a fraction. So the opposite of division is multiplication. So I'll multiply each side by 5.7. 5.7. So I'm just going to do 5.7 times 0.68. And that'll get me a final answer down here of x equaling, let's just call that 3.87. So that's our missing side length from our triangle up here. Is right here, 3.87. So now at this point, all we're going to do is the Pythagorean theorem to figure out our last side length. So I'm going to do 3.87 squared plus 5.7 squared equals our hypotenuse, or c squared. So when I do 3.87 times 3.87, I get about 14.98. When we square 5.7, we should get about 32.49. Add those two together. And we'll get 47.47. And then last but not least, we just take the square root of each side. and we'll get about 6.9. And that'll be our hypotenuse. So if we kind of move everything back down, we just figured out here now that we have about 6.9 as our distance here. Alright, that's all I got for you guys today. If you have any questions, feel free to email me, and I will see you all in class.